In this video, we look at two sinusoids. V1 equals to minus 10 cosine omega t plus 50 degree. V2 equals 12 sine omega t minus 10. We want to find out which sinusoid is leading. To solve questions like this, we want to express V1 and V2 in the same form, either a cosine or a sine without a negative sign at the front. So let's express both waveform into the format of cosine. Of course, you can choose express it into sine. That's doable too. Okay. V1 equals to minus 10 cosine. Here, we want to get rid of this minus sign here. Otherwise, you cannot compare the phase. And we want to use one of the formulas provided in the textbook. Here I want to point out the notation in the textbook is a little misleading here. For example, if we look at it, this is omega t and this is omega t. And really this omega t is just a general argument. It really should be replaced by alpha and alpha. The confusion comes from here. If this is omega t, and then we use the formula, they relate this omega t and this omega t together. Here, I want to point it out that treat omega t in the formulas as a general argument. So it's really helpful to write formulas like this. Cosine alpha plus or minus 100 degree equals to minus cosine alpha. And the whole thing here, this is alpha. So now we want to get rid of the minus sign in front of cosine alpha. So we're going to use this formula. Minus cosine alpha equals cosine alpha plus or minus 100 degree. Remember, this is the alpha, so plus or minus 100 degree. We're using this formula. Now we want to look at this because there is a plus and minus, and let's look at these two cases. The first case, we want to look at minus sign here. This will be omega t minus 130 degree. And then the second option is plus 180 degree. That will be omega t plus 230 degree. So we finish express v of t into the format of cosine. Now let's look at v of 2. V of 2 has a format of sine. We want to convert it into cosine. So we want to use this formula here. So plus sine omega t equals cosine omega t minus 90 degree. So remember, omega t here is alpha, and this is alpha. This whole thing is alpha. Alpha minus 90 degree. So this is how we convert v of 2 into cosine. Now if we compare A1 and B1, A1 and B1, we can see V1 has a phase of minus 130 degree, and B2 and V2 has the phase of minus 100. Therefore, V2 beats V1 by 30 degree. Now, how about if we compare A2 and B1? From A2, V1 has phase 230 degree, and from B1, V2 has phase of negative 100 degree. So therefore, we would have compared A2 and B1, we would come to the conclusion V1 leads V2 by 330 degree. Normally this quantity here, by how much the phase leads or lag, normally is less than 100 degree. It should, preferably it should less than 100 degree. It should less than, but now is greater than 100 degree, which is not normally we wanted. So normally we express this quantity by less than 100 degrees. So how do we fix that? Now we're going to change V2 a little bit using this formula. Cosine beta equals cosine beta plus 360 degree. Now from B1, add 330 degree here. So now if we compare A2 and B2, so A2, the phase is 230 degree, and B2, the phase is 260. We come to the same conclusion. V2 leads V1 by 30 degree. In summary, to handle the question like this, we want to express two waveforms, two sinusoids in the same format, either cosine or sine. So now we express into cosine. We need to get rid of this minus sign here. Remember, the formula in the textbook is a little misleading, so we should treat omega t in the formulas by a general argument, which is alpha, beta, whichever we want. Okay, so the whole thing here is treated as alpha, and then we use the formulas here. Another thing is that the formula, when we use the formulas, we want to look at from the right side to the left side. So we want to convert this minus cosine into cosine. So really we work the formula from the right to the left. There are two options here. We look at these two options already, and then we compare the phase of two waveforms. The quantity of phase leading or lagging preferably should less than 180 degree. That's the common norm. If it is greater than 100 degree, we need to do some more reorganizations.